When dealing with a service entrance panel installed in 1960 that lacks a main breaker and contains 10 breakers, it is essential to consider current electrical codes and safety standards to determine if an upgrade, including the addition of a main breaker, is required. Older electrical installations often do not meet modern safety requirements, and bringing them up to code is crucial for preventing electrical hazards. A service entrance panel distributes electricity from the utility company to various branch circuits within a building. A main breaker serves as a primary overcurrent protection device, disconnecting all power to the panel in the event of a significant fault, overload, or short circuit. This provides a critical safety feature, minimizing the risk of electrical fires and equipment damage. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations. While the NEC is not law unless specifically adopted by a local jurisdiction, it serves as the basis for most electrical codes and is updated every 3 years to reflect advancements in technology and safety practices. If the local jurisdiction has adopted a more recent version of the NEC, the panel may not meet those requirements. Generally, modern electrical codes require a main disconnect, which can be a main breaker, for service entrance panels. The purpose is to provide a single point to quickly and safely disconnect all power to the building or structure. Without a main breaker, it can be difficult to energize the entire panel in an emergency, posing a safety risk to occupants and emergency responders. The presence of 10 breakers in the panel further emphasizes the need for a main breaker. Each breaker protects an individual branch circuit, and without a main breaker, the cumulative load on the service entrance conductors is not adequately protected. If the total load exceeds the capacity of the service entrance conductors, it can lead to overheating, insulation damage, and potentially an electrical fire. Evaluating the existing panel involves several steps. Firstly, determine the ampacity of the service entrance conductors. This can be identified by checking the conductor size and insulation type, and referencing the appropriate ampacity tables in the NEC, such as Table 310.15b16. Secondly, assess the load on each of the 10 breakers. Measure the current draw of each circuit under normal operating conditions to determine the actual load. Thirdly, calculate the total load on the panel by summing the loads on each breaker, taking into account any applicable demand factors. Demand factors allow for the fact that not all circuits will be operating at their maximum load simultaneously. The NEC provides guidance on applying demand factors for various types of loads, such as lighting, appliances, and motors. Fourthly, compare the total calculated load to the ampacity of the service entrance conductors. If the total load exceeds the conductor ampacity, the panel is overloaded and requires an upgrade. Even if the total load is less than the conductor ampacity, the absence of a main breaker may still violate current electrical codes. Check the local electrical codes and regulations to determine the specific requirements for service entrance panels. Many jurisdictions require a main disconnect for all new installations and upgrades. The main disconnect must have an ampacity equal to or greater than the calculated load, but not less than the ampacity of the service entrance conductors. Adding a main breaker involves several considerations. Firstly, select a main breaker with the appropriate ampacity. The breaker must be rated to interrupt the available fault current at the service entrance. This is typically determined by a short circuit study. Secondly, install the main breaker in a suitable enclosure. The enclosure must be properly sized to accommodate the breaker and provide adequate working space. Thirdly, connect the service entrance conductors to the main breaker. Ensure that all connections are properly torqued and insulated. Fourthly, bond the enclosure to the grounding electrode system. This provides a low impedance path for fault current to return to the source, minimizing the risk of electric shock. It is crucial to consult with a qualified electrician or electrical engineer to perform the necessary calculations, select the appropriate equipment, and ensure that the installation complies with all applicable codes and regulations. Attempting to perform electrical work without the proper training and experience can be dangerous and may result in serious injury or property damage. Furthermore, improper electrical work can void insurance coverage and create potential liability issues. In addition to adding a main breaker, consider other potential upgrades to the service entrance panel. These may include replacing outdated or damaged breakers, adding surge protection devices, and improving the grounding system. Surge protection devices protect sensitive electronic equipment from voltage spikes caused by lightning strikes or other electrical disturbances. A properly grounded system minimizes the risk of electric shock and provides a path for fault current to return to the source. When evaluating the existing panel, also inspect the condition of the wiring. Look for signs of damage, such as cracked or brittle insulation, loose connections, or corrosion. If the wiring is in poor condition, it may need to be replaced. Aluminum wiring, which was commonly used in the 1960s, can be particularly problematic. Aluminum wiring is more prone to oxidation and expansion and contraction than copper wiring, which can lead to loose connections and overheating. If the panel contains aluminum wiring, consider replacing it with copper wiring or using approved connectors and termination methods specifically designed for aluminum wiring. Another consideration is the available space in the panel. If the panel is already crowded, it may be difficult to add a main breaker without replacing the entire panel with a larger one. A larger panel provides more space for breakers and wiring, and can also accommodate future expansion. When selecting a new panel, choose one that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or ALL. This ensures that the panel meets established safety standards and has been tested for performance and reliability. Also, ensure that the panel has sufficient interrupting capacity to handle the available fault current at the service entrance. The interrupting capacity is the maximum amount of fault current that the panel can safely interrupt without causing damage. The presence of 10 breakers also necessitates checking the load balance across the phases. Uneven load distribution can lead to voltage imbalances, which can damage electrical equipment and reduce efficiency. Use an ammeter to measure the current on each phase and adjust the breaker positions to achieve a more balanced load. Balancing the load can improve the overall performance and reliability of the electrical system. Furthermore, consider the future needs of the building or structure. If there are plans to add new electrical loads such as appliances, equipment, or lighting, ensure that the service entrance panel has sufficient capacity to accommodate these loads. Oversizing the panel slightly can provide flexibility for future expansion and prevent the need for costly upgrades later on. When upgrading the service entrance panel, it is also important to update the panel schedule. The panel schedule is a directory that identifies the circuits served by each breaker. An accurate and up-to-date panel schedule is essential for troubleshooting electrical problems and ensuring that the correct circuits are energized for maintenance or repairs. The panel schedule should be clearly labeled and posted near the panel. Consider using a computer-based panel schedule program to create a professional and easy-to-read schedule. Additionally, ensure that all wiring is properly labeled. Label each wire with its circuit number and destination. This makes it easier to trace circuits and identify wiring problems. Use a wire labeling machine or pre-printed wire labels to ensure that the labels are durable and easy to read. Proper labeling can save time and effort when troubleshooting electrical issues. When performing any electrical work, always follow safe work practices. Wear appropriate personal protective equipment, such as safety glasses and gloves. De-energize circuits before working on them and verify that they are de-energized using a voltage tester. Use insulated tools and equipment. Never work on live circuits unless absolutely necessary, and then only with the proper training and precautions. Electrical work can be dangerous, so it is essential to take all necessary safety measures. Upon completion of the upgrade, thoroughly test the new installation to ensure that it is functioning properly. Check the voltage and current on each circuit. Verify that the breakers are tripping properly. Inspect all connections for tightness and security. Conduct a ground fault loop impedance test to ensure that the grounding system is effective. Document the results of the testing and keep them on file for future reference. Regular maintenance of the service entrance panel is essential for ensuring its continued safe and reliable operation. Inspect the panel regularly for signs of damage, such as corrosion, loose connections, or overheating. Tighten any loose connections. Replace any damaged breakers or wiring. Clean the panel to remove dust and debris. Schedule a professional electrical inspection every few years to identify any potential problems before they become serious. A qualified electrician can perform a thorough inspection of the panel and recommend any necessary repairs or upgrades. In summary, if a service entrance panel built in 1960 does not have a main breaker and there are 10 breakers, it is highly likely that an upgrade to add a main breaker is required to meet current electrical codes and safety standards. This involves evaluating the existing panel, calculating the total load, comparing the load to the conductor ampacity, checking local electrical codes, selecting a main breaker with the appropriate ampacity, installing the breaker in a suitable enclosure, connecting the service entrance conductors, bonding the enclosure to the grounding electrode system, and consulting with a qualified electrician or electrical engineer. In addition to adding a main breaker, consider other potential upgrades to the service entrance panel, such as replacing outdated or damaged breakers, adding surge protection devices, improving the grounding system, and replacing aluminum wiring. Always follow safe work practices when performing electrical work and thoroughly test the new installation upon completion. Regular maintenance of the service entrance panel is essential for ensuring its continued safe and reliable operation. By following these steps, you can ensure that the service entrance panel is safe, reliable, and compliant with all applicable codes and regulations. Remember to always prioritize safety and consult with qualified professionals when performing electrical work. This ensures that the work is done correctly and that the electrical system is safe for occupants and property.